Hello, my dear friends. Very good morning to everyone. I welcome you to my YouTube channel and Talukdar Maths. Those who yet not subscribe my channel, please subscribe my channel. Through my channel, I can help you to develop your interest in the subject mathematics and the skill of solving mathematical problems. Today I am going to discuss few problems related to the topic continuity. In earlier classes I have given the detailed concept of the particular chapter. Now the first problem is show that the function f(x) is equal to sin x is a continuous function. In class 11 you got the graph of the function, and from the graph is the from whole domain the graph is like that. Okay, understood? And from the graph it is clear that the function is continuous function, but how we can show mathematically the function is continuous? Since the main of the function is the set of real numbers, so we can take C is any real numbers, and our aim is to show that the function is continuous at C, and then we conclude that it is a continuous function. We know that a function is continuous when it is continuous at every point in its domain. That is very important. Here C is a point in the domain. Here x is approaches to from right and is denoted by x tends to C plus, and x is approaches to C from left. You can write x tends to C minus, and x tends to C plus means x equal to C plus h, and x tends to C minus means x equal to C minus h. That means both together can be written as x tends to C, and x tends to C can be written this one or that one. Here I am supposing x is equal to what? C plus h. What is h? H is a very small quantity and positive. X tends to C implies what? H tends to 0. Now take limit. Also f of c, value of the function at c equal to what? From the function you see fc equal to what? Sin c. Now limit x tends to c, fx is equal to what? Limit x tends to c, fx means what? Sin x, and x tends to c means what? H tends to 0. When change your limit, immediately x is changed to what? C plus h. Okay. Now this can be expanded by the formula sin a plus b, sin a cos b plus cos a sin b type formula. Okay, you understand, I think. Now sin c is a constant quantity, and constant quantity can be come out from the limit, and limit also can be separated. Sin c into limit h tends to 0 cos h. Similarly cos c can come out, limit h tends to 0 sin h. If you put limiting value here, you will get sin c cos h is equal to, or cos 0 is equal to 1, so it can be 1, and if you put h is equal to 0, then sin 0 equal to what? 0, and finally your result is sin c, and sin c is nothing but what? fc. Clear, everybody? So what we conclude that limit x tends to c, fx is equal to what? fc, and this is the definition of a continuity of a function at a point. So f is a continuous at x is equal to c. But what is c? C is an arbitrary real number, is any real number. So we can conclude that fx is equal to sin x is a continuous function. Okay, I hope you understand this problem very easy. Now I am going to moving ahead with my next problem. The problem is discuss the continuity of the function fx is equal to sin x plus cos x. Discuss. The meaning is that you have to discuss at all points in domain. You have to discuss all the cases. Okay. So at all points you have to discuss. When you find that in every point the function is continuous, then you can conclude that the function is continuous function. Okay. Here the function is the sum of two functions. We suppose that gx is equal to sin x and hx is equal to what? Cos x. Okay. Then your original function becomes what? Fx is equal to gx plus sin hx. If we can prove that gx is continuous and hx is continuous, then sum of two continuous function is a continuous function as per the algebra of continuous function. I have already mentioned this in the last class. The domain of G is R. Domain of sin x is set of real numbers. Domain of cos x is set of real numbers. And therefore domain of F is the intersection of domain of G and domain of H. And finally it is the set of real numbers. So our aim is to show that the function is continuous at all real numbers. Let C belongs to V or any real numbers. Then first our aim is to show that Gx is continuous. So what is the functional value at C? Gx is equal to sin x, so Gc equal to sin C. This was the previous problem, okay? This was the same as previous problem. So I am not going to explain this, just take x is equal to C plus h and how it is come, and then limiting value, and it becomes limit x tends to C sin x. Sin x can be written as sin C plus h, and x tends to C means h tends to 0. When you express x in terms of h, you have to change the limit x to limit h. So you expand the formula and finally you get sin C, okay? And sin C is equal to what? Gc. And therefore G is continuous at C, at x is equal to what? C. And what is C? C is any real number, and therefore G is a continuous function. That means sin x is a continuous function. Sin x is a continuous function, okay? Sin x is a continuous function. Clear? That's my problem. Sin x is a continuous function. Clear? Now sin x means G is continuous function. Similarly, you can prove that hx is also a continuous function. Hx also continuous function. So you can write here, similarly hx is equal to cos x is also a continuous function. Also a continuous function. Therefore fx equal to gx plus hx is also a continuous function. Hence we prove it. From this step, G is continuous at x equal to C. Here one statement you have write. Therefore C, since C is an arbitrary real number, okay, so arbitrary real number, from here you can write G is continuous function. Then from here you can move ahead, okay. So I hope you understand this problem also. Let us start with a new problems, another problem which is very interesting for you, very interesting, okay. Question is that find all points of discontinuity of the function fx equal to what? Sin x by x if x less than 0, and fx equal to what? X plus 1 if x greater than equal than 0. So from this condition you see x less than 0, x greater than 0, x equal to 0. So this condition represent the domain of the function is the set of real numbers. Okay, this is 0, this is x greater than 0, this is x less than 0. Okay, so finally domain is the set of real numbers. There are three cases we have discussed one by one. First case, when x less than 0, your function is sin x by x. We already proved that sin x is a continuous function. And what is x? X is an identity function which is also continuous. And finally sin x is continuous, x is continuous. So by Cotton rule, sin x by x is also a continuous function, and hence fx is continuous function. Clear? When x greater than 0, fx is equal to what? X plus 1, which is a polynomial function, and hence it is continuous for all x greater than 0. So simply in both the cases, for all positive real numbers greater than 0, that means all positive real numbers and all negative real numbers, the function is continuous. Now we are going to show that whether the function is continuous at x is equal to 0 or not. Here x is equal to 0 is a particular point. It is a particular point. So here we are going to use the left hand limit and right hand limit, and also value of the function. If all these three are equal, we can conclude that the function is continuous. Now at x is equal to the left hand limit x tends to 0 minus fx. Okay, limit x tends to 0 minus fx. And when x tends to 0 minus means what? X tends to 0 minus means what? X is less than 0. Okay, x is less than 0. And when x is less than 0, your function is what? Functional value is equal to what? Sin x by x. Clear? From the function you see this is your function. Okay, when x less than 0, when x less than 0, fx is equal to sin x by x. X tends to 0 minus means what? X less than 0. And when x less than 0, fx is equal to sin x by x. Okay. Now when x is less than 0 means x can be taken as a number which can be subtracted from 0, a small number. What is h? H is a small quantity. You have mentioned it, h is greater than 0. Okay. So x can be taken like x tends to c minus means what? Remember it, x tends to c means x can be taken c minus h. Okay. So here c means 0. So x is equal to 0 minus h, here h tends to 0. X tends to 0. If you put x equal to 0 here, automatically h is equal to what? Tends to 0. So replacing x tends to 0 minus means what? H tends to 0, and immediately x is replaced by minus h. Sin minus h is equal to minus sin h, and minus से क्या होगा? Cancel होगा. And we know that limiting value of this is what? Value is 1. Okay. Now comes to right hand limit. Limit x tends to 0 plus fx. X tends to 0 plus means what? X is greater than 0. When x is greater than 0, what is your functional value? Functional value is what? X plus 1. Okay. Functional value is what? X plus 1. So you can write x tends to 0 plus x plus 1. Fx is equal to x plus 1. Okay. Because x is greater than 0. And when x is greater than 0, you can write x is equal to what? 0 plus h. X tends to 0 means h tends to 0. Okay. So replacing x by h when limit is changed to h. Okay. So finally you put the result, you get 1. Then also functional value f0 equal to what? 0 plus 1. You know that when x is equal to 0, fx is equal to x plus 1. So f0 equal to 0 plus 1. Ultimately you get 1. So finally what we get? Left hand limit is equal to right hand limit is equal to what? f0. That means f is continuous at x equal to 0. Since in all the cases the function is continuous, that means the function is continuous throughout its domain. Throughout its domain, and hence there is no point of discontinuity of the function. Since function is continuous at every point means there is no point of discontinuity. So I hope you understand this problem, very interesting one, and this type of problem asked regularly in the examinations. Go through the problem, practice it, and also solve more problems, then you can get overall idea how to solve such type of problems. Thank you very much for listening my lecture and also attending my classes. Thank you.